this lesson, we'll continue to look at mass-to-mass stoichiometry and using that to determine the percent yield in a chemical reaction. So in this homework problem, it says, what is the percent yield of aqueous solutions containing 6.24 grams of potassium sulfide? So potassium is K and sulfide is S. And if we have potassium has a 1+ charge and sulfide has a 2- charge, so we're going to need 2 potassiums to balance the charge. So that should be K2S. And we also have reacted with a solution containing 19.25 grams of potassium nitrate. Well, barium nitrate. Barium is Ba and nitrate is NO3. And barium has an atomic or a charge number of 2+. Nitrate has a 1- charge, and that's on your common ions list. Nitrate is 1-, and so we're going to need 2 nitrates to balance out the charge on the barium. So that's BaNO3, and the NO3 is inside of parentheses and the 2 outside. And then it says we're collecting 8.12 grams of precipitate. So we have to figure out what the precipitate is. So let's figure out what our physical states are first. These 2 compounds. So potassium is a group 1. It's a group 1 metal. It's found right here in column 1. And it says on the solubility rules that all group 1 salts are always soluble with no exceptions. So this is going to be aqueous. Nitrates are also always soluble with no exceptions. And then we're going to take and put the front part of this with the back part of this and have KNO3. K has a 1+ charge, NO3 has a 1- charge, so that's already balanced. And we said that all nitrates and group 1 salts are always aqueous, so this is going to be aqueous. And then we're putting Ba with S. And sulfides are insoluble most of the time. There's exceptions for group 1, group 2, and ammonium. We said that barium is in group 2, so this is also aqueous. So the question that some may have is, how in the world are we going to have this happen when so far you've learned that this is going to be no reaction? In fact, when we say aqueous, that's a relative term. And since the problem says we're going to collect 8.12 grams, it means that there's got to be some kind of a precipitate or some way to collect it. You just don't know what it is yet. Okay? And what it says down here, in fact, insoluble by definition means that a precipitate forms when equal volumes of 0.1 molar solutions or greater are mixed. So if we had greater concentration, we could still get a precipitate. Or there are other ways to collect those kind of things. Okay? You can, in some cases, like this compound would precipitate at a lower temperature than this one would. In fact, I know for a fact this compound will precipitate at a lower temperature. So you could lower the temperature and keep this in solution and get some of this to precipitate out. So there's different ways to do that. We just haven't talked about them yet. All right? So there is a way to get this out. Obviously, that has to be the case if we're going to have 8.12 grams of precipitate. All right, so we need to balance the equation now. So K and S and Ba, N, and O are the elements we have in the equation. So we're going to use an atom inventory to balance this. I'm going to count the elements we have on both sides of the equation. So I've got a line directly under the arrow here, and everything I'll put on this side is what's on this side of the equation. What I put on this side of the arrows is what's on this side of the equation. So we've got 2 potassiums and 1 sulfur, 1 barium. The 2 on the outside of the parentheses means I have 2 of everything inside. The nitrate polyatomic ion actually has only 1 nitrogen, but the 2 outside means I have 2 nitrates, so I have 2 nitrogens and 6 oxygens. On the other side, I've got 1 potassium, I've got 1 sulfur, I've got 1 barium, 1 nitrogen, and 3 oxygens. So we want to use coefficients now to balance the overall equation. Oh, I haven't pointed out that barium has a 2+ charge, sulfide has a 2 negative charge, so one of each of those will give you a neutral compound. So that formula is balanced. So I'm going to go use only coefficients. Once the formulas are balanced, we only use coefficients, that is numbers in front of the whole formula, to balance the equation. So since I have 2 potassiums on the left side, to get 2 on the right side, I'll put a coefficient of 2 in front of this chemical species. That's going to change the number of potassiums, nitrogens, and oxygens. So the 2 here means I multiply everything in the formula by 2. So I now have 2 times 1 or 2 potassiums, 2 times 1 or 2 nitrogens, and 2 times 3 or 6 oxygens, and that balances the equation. So we have in the question, let me put this back up on the screen for you. In the question it says we have 6.24 grams of potassium sulfide and 19.25 grams of barium nitrate. What we're going to do here is to figure out which of those two reactants is the limiting reactant. We want to find out, is this the limiting reactant or is this one? So I'll start, it doesn't matter which one of those 2 you start with, because you've got to do the math with both. We're going to start with 6.24 grams of potassium sulfide. We'll put that over 1. In order to go from potassium sulfide to the species we want to collect at the end. Oh, I didn't tell y'all which one was the precipitate, did I? Sulfides. Okay. So you guys might not know which is the precipitate. How many of you did anybody choose this to be the precipitate? Did anybody choose this one to be the precipitate? Okay. Well, that's more likely to be the precipitate. So it looks like everybody who made a choice chose this one to be the precipitate. Okay. How would you know? Yeah. Well, at this point, you wouldn't know. I should have told you yesterday. I didn't think about it when I did it, because you guys wouldn't know that this would precipitate at a cooler temperature. But so it's like everybody made the right guess anyway, those who guessed anyway. So, and nobody asked me, so I could have told you that. But anyway, let's see. So we need to be, in order to go from one chemical species to another, I've got to go through a molar ratio. So I've got to get this into moles to do that. And for that, we're going to have to calculate the molar mass of potassium sulfide. So we've got potassium and sulfur. We'll look on the periodic table and see that the atomic mass of potassium is 39.0983. And the atomic mass of sulfur is 32.065. We've got 2 potassiums. We've got 1 sulfur. 2 potassiums. 78. Right. Okay, 78 point what? 19. Okay, and we've got 1 sulfur, 32.065. We're going to add those together. 6, 11, carry 1, 16, carry 1, 2, 10, 10, 11. So, decimal place. Is that what you got? Yep. Okay. And we've got 1 empty slot, so that number has to be rounded off. I'm going to draw an arrow. That's the only allowed operator to show that you're rounding off. And we get 110.26. This 6 here is 5 or greater, or greater than 5, so it's going to round this 1 up to a 2. Well, I'm trying to get the calculator up, so. Bring that down here. All right, so we got 110.262. That's grams of potassium sulfide. And you have to say that's equal to 1 mole. of potassium sulfide. You have to write that equality statement every time. Now, with this equality statement then, we can build a conversion unit. I want to match the units and species I have on the top of this fraction with the units and species I put on the bottom down here. This side of the equality statement has the same units and species. So we'll put that number on the bottom, 110.262 grams of potassium sulfide. And 1 mole goes in the top. 1 mole of potassium sulfide goes in the top. And we can cancel out and simplify. The grams cancel, potassium sulfide cancels. Now we're ready to do a molar ratio because we've got our starting amount in moles. And we use a balanced equation for that. So we have potassium sulfide here. We have one of those. There's a coefficient of 1 that's implied here, and a coefficient of 1 that's implied here with the barium sulfide. I want to match units and species that I have on the top here with what I put on the bottom here. So this 1 mole of potassium sulfide is what I put on the bottom here. And then the 1 mole of barium sulfide goes in the top. Okay. So now we're ready to simplify again. We can cancel out moles and potassium sulfide. We now have moles of barium sulfide. And we need to calculate the molar mass of barium sulfide to build a conversion unit here and get the mass. So the atomic mass of barium is 137.327. And the atomic mass of sulfur we already found was 32.065. Since I only have one of these, I don't really need to multiply by 1. I could just add these together. This is the only case where you don't have to do the times something over here. I'm going to add these together. Did I write that down? Yeah. Okay. So let's see. This is 12, 9, 3, 9, 6, 1. Now, there's no empty slots over here to the right either, so we had to round off because of the empty slot here. Here, there's no empty slots to round off. All right, so this is going to be then grams of barium sulfide equals 1 mole of barium sulfide. Okay, and from that, then we can build a conversion unit. We want the units and species we have on the top here to match the units and species we put on the bottom here, and that's this side of the equality statement. So 1 mole of barium sulfide goes on the bottom, and 169.392 goes on the top. And that's grams of barium sulfide. Look, you have to put your units and species with every number, guys. I've been watching some of your work, and some of you are not putting units and species every time. If you don't have units and species, you don't know what you're doing. Okay, you'll get to the end of the problem, you can't figure out why you went wrong. You have to have units and species with every number. Anytime you know what the units are, you have to write them down with the number. We talked about that in Unit 1. Okay, anytime you have a species that you know apply that unit, that number, the measured number, and the units of measurement apply to, you have to write it down. So moles cancel and barium sulfide cancels. We're ready to do the math. And so we're going to take this number and multiply it by that number, hit equals, and divide by that number, and equals again. That's the fast way to do it that works on every calculator. So we'll take 6.24 times 169.392 and hit enter, then hit divide by, and put in 110.262. And that's going to give us 9.58631. Now, most of your calculators probably gave you a lot more digits than that, and that's okay. You put down the number of digits your calculator actually shows. The units we have left are grams. The species we have left is barium sulfide. We want to figure out our significant digits, and we can see that of the measured and calculated numbers in this problem, this number here has the least digits. Measured and calculated numbers would be this one and this one and this one. All these ones here are all counting numbers, so we don't use the counting numbers for determining significant digits in multiplication and division. So since I have 3 significant digits here, I want to match the same number of significant digits in the answer. So after the first 3 digits, those are significant. We're going to underline all the other digits because those are insignificant. Draw an arrow to show a rounding off, and write the rounded answer, 9.59 grams of barium sulfide. Okay, so that's our mass-to-mass calculation to find a mass of barium sulfide, but that's only the first half of what we have to do to figure out a limiting reagent or limiting reactant. The other thing we have to do is to do the same kind of math, but starting with the other reactant. So let's take a look at the problem again, and we see that we're starting with 19.25 grams of barium nitrate. So 19.25 grams of barium nitrate we're going to put on the top of this fraction. We're going to need a molar mass ratio, so we've got to calculate the molar mass of barium nitrate. So barium and nitrogen and oxygen are the elements we have in the compound. Barium's atomic mass is 137.327. Nitrogen's atomic mass is 14.0067, and oxygen is 15.9994. In the formula for barium nitrate, we've got one barium, we've got two nitrogens, and we've got 6 oxygens. So we'll put 137.327 and 14.0067 times 2. 14.0067 times 2 gives me 28.0134. And then 15.9994, whoop, or times 0.4 times 6, what? Okay, and now we're going to add all these together. And we get 261.337. $261.337, is that what I said? Okay. Yeah, it should be 6.8 because I calculate on my computer puts fewer digits up to simplify things for you. So it should be 6. That's what I was going to point out. It should be 6.8 on the end, which would round off because of that empty slot here. This is going to round off, and you will get that. So 261.337, and that's grams of barium nitrate equals 1 mole of barium nitrate. Okay? And so that's the equality statement we use to build this conversion unit. Again, we're matching the units and species we have here on the top of this fraction with what we put on the bottom, and that's this number with this unit and species. So 261.337 grams of barium nitrate. And then 1 mole goes in the top. 1 mole of barium nitrate goes in the top. One of the things that students sometimes seem to get confused about is this 1 mole. If you will write out every time you calculate the molar mass, and this is what's required in this class, if you'll write it out when you calculate the molar mass, you write out this mass or grams of barium nitrate equals 1 mole. Notice how I've done that every time. This mass is equal to a mole. This mass is equal to a mole. That's what molar mass is. If you'll do that every time, this won't be confusing to you. Sometimes students want to know, well, do I use the coefficients up here? No, you don't do that. It's only the formula you're calculating with, not the coefficients at all. Just the formula you're calculating with, and it's always equal to 1 mole. The coefficient moles, that's taken care of in the molar ratio, which is the next step here. In the molar ratio, now we're going to look at coefficients. So now we're starting with barium nitrate, and there is, in this case, 1 mole of barium nitrate. and we're trying to get to barium sulfide, and in this case there is only 1 mole of barium sulfide. And now we got to convert it back to grams, or convert barium sulfide back to grams. I haven't canceled here. Let's cancel and simplify. And so we've already calculated the molar mass for barium sulfide. We can just plug that in here now. We've got moles of barium sulfide here, so I want this side of the equality statement on the bottom to match the units and species, 1 mole of barium sulfide. And the top I'm going to put 169.329, or 392 rather, grams of barium sulfide. And we're ready to do this math, okay? Well, let's cancel out here first, get this all nice and neat. So we're ready to multiply this number times this number, then hit enter and divide by that number. So 19.25 times 169.392, hit enter, and then divided by 261.337, and hit enter again. So we've got 12.4774 grams of barium sulfide. And looking at all the measured and calculated numbers in the problem, this number has the least digits. There's 4 here. So we're going to count 1, 2, 3, 4 and underline everything else. Those are 2 digits here, the insignificant digits. And we're going to round this to 12.48 grams of barium sulfide. So, what we're going to do now to figure out a limiting reactant is compare these 2 masses. You've got 2 masses for the same product. And this is a lower number than this one is. Okay? So, if this is the lower number, this is your limiting, this is your theoretical yield, and this chemical species here, K2S, is the limiting reactant. Okay? So this is our theoretical yield. And this species here, K2S, is the limiting reactant. So what we're finding out here is that this is the largest amount of barium sulfide that can theoretically be created. Okay? If that's a smaller amount, there's no way you can get the larger amount. What's happening is this is running out first, or running out before this runs out. And so you stop when this runs out to make this. That's why this is the limiting reactant. This species is the limiting reactant here, and this is the theoretical yield. Now that we have the theoretical yield, we're ready to calculate percent yield. So we go back to our problem now, and we see in the problem that 8.12 grams of barium sulfide was collected. So we're going to use that number and the theoretical yield to calculate percentage yield. And so we put that over the 9.59, which is our theoretical yield. So this is the actual yield. It's the amount actually collected. This is the theoretical yield. And percent yield is always actual over theoretical, and then times 100. Okay. So 8.12 divided by 9.59, and then times 100, and we get 84.6715. And we're going to round that off properly. So there's 3 digits in this number and 3 in this, and the 100 doesn't count. Okay, that's an absolute number. So we don't use that. It's kind of like a counting number. We don't use it at all for figuring out significant digits. We've got 3 digits in these 2 numbers. We want 3 digits in our final percentage number, and we get 84.7%. Now, it's not enough, guys, to write 84.7%. You've got to tell me what that applies to. Okay? Well, actually, it's not grams, because the grams actually are supposed to cancel over here. Grams cancel and barium sulfide cancels here. Okay? It is a percentage It's the percentage yield. And you can say in or of barium sulfide. Okay, so that's the proper way to say it. All right, or a reasonable way to say it. There's probably other ways to say it that's perfectly good, but you have to be specific about what the percentage applies to. It's not enough to just write down a percent. Be clear about what it applies to. Any questions about this? All right, we got a guest teacher. Here we go.
What is that supposed to
It
mean?
means that you're a guest teacher. Hurry up.
Well, your table is different than mine. Thank you very much.
Y'all gonna stick around after the bell? Then no extra time?
Okay.
You know, it's right. It's on December the 1st.
You know how like you know how you do the makeup test? You know like when you get
Hold on, hold on.
They make it on home.
Oh, the homework form's already done.
You just give us the same thing when you change the words.
Yeah, the numbers.
We change the numbers. Yeah, that says.
Change the word.
All right, what's the question?
You know like okay, you try to do like
Uh-huh.
you know when you get closed off like where you actually have to do like problems. You still have to redo those when you get to the not the whole problem.
Yeah, if you miss any points at all, you have to redo it. The corresponding questions are there, yeah.
Is the makeup
Are you
test
gonna
already
send
made?
that out?
Huh?
Is the makeup test already made?
For the last test?
No, for this one. For this.
Oh.
For this unit?
Yeah.
The one that we just took.
Yeah,
Yeah,
that
it's on the website.
I'm not sure what that is.
The idea is you look them up. I mean, you get help with what you don't know.
I only got one.
No, that's not cheating. That's exactly what I want you to do.
You gave me 1 point for total question.
Yeah, that's right.
I only got 1 point for each part. You know how you count every little thing? Got 1 part for me.
Okay?
A 73.
So let's see, 4.98 grams of calcium chloride.
Ooh,
That's all right. We'll get it back on the screen. We're good. All right.
What? Yeah.
Yeah.
Yeah, this is the second the mass calculations you're doing.
Oh my gosh. What? I think I just did it on purpose. Yeah.
What? While you're up there, make sure that you
I will. I will. What was this called again? It's called theoretical yield, right?
that's what theoretical is.
And it's also the,
Actually, the rest of the class is watching and telling you that not.
they don't know what it is.
That you would write yield of calcium chloride. Okay? That's the complete statement, alright? And then go back to cancel units.
I was getting there.
And then yield.
What?
Okay, good. Alright. Very good. Nicely done.
Thank you very much.
Good job, David.
Alright, here's your homework problem.